Hi. This last presentation in the FSMD playlist proposes a third coursework assignment that revisits the DICE specification, but now designed as a finite state machine with data path. At the end of the presentation, I expect you to be able to explain the functional requirements in your own words and to be able to plan the tasks needed to implement your solution using Vivado. The presentation comprises two parts, starting with the functional requirements and ending with the list of tasks. Let's start by the requirements, which in this case are exactly the same as those presented for the implementation using a finite state machine. The overview representation is therefore the same that we have seen in the previous coursework assignment. And likewise, the functional requirements, since the difference lies only in the architecture adopted to implement a solution. Recall that we are asked to support three cheating modes comprising the triple probability for any result, a predefined result mode, and a forbidden result mode. And here's the difference to the previous finite state machine-based implementation. In this case, we want to develop an FSMD-based solution where a standard finite state machine is used to design the control path, and the data path may be set up comprising two counters and one decoder. The operation of the result counter is similar to what was used in the first assignment addressing a counter-based implementation, and now we have an additional 2-bit counter that will be used to count the number of times the cheating result will be repeated. Let's move on to consider the tasks associated with this implementation. You may notice that the block diagram shown earlier represents a more complex architecture when compared to the counter-based or finite state machine-based implementations, but on the other hand, you will see that the corresponding FSMD chart will be simpler and may actually be designed with only two states. In this type of implementation, the project work is now essentially related to designing the FSMD chart and the data path units. You may start by considering that the FSMD chart will comprise only an initial state and a run-stop state, and try to represent all the decision boxes and conditional output boxes that need to be present in each ASM block. Once you believe to have reached a solution, you can start to convert the FSMD chart into an equivalent VHDL description. In this case, it's once again better to consider a hierarchical structure description where the top level interconnects the control path and the data units. You will need to create the VHDL design files for each block, and then bring everything together and check that you are able to synthesize without errors. The following stage is to create a simulation source file for design verification. You may use the same simulation source file created for the FSM-based implementation, since the input and output ports are exactly the same. If the simulation waveforms confirm operation as expected, you are ready to move on. Last stage is implementation and starts by creating the constraints file. Once again, you can use the same constraints file that is available from the finite state machine-based implementation, since the pins are the same. Once the file is added, you are ready to generate the bit stream and to program the FPGA, and then you can try it out in the Basis 3 board. And this concludes the FSMD playlist. Thanks for your attention.